Every day, humans consume food in order to meet daily caloric intakes along with other specific nutrients. When preparing or storing food, the properties of heat transfer play a role through convection, conduction, and radiation. Mass transfer is also involved when cooking and often is caused by heat transfer. The diffusion of gases and liquids can occur when cooking. When boiling water, there is mass transfer caused by the diffusion of water vapor and oxygen. After you eat or drink, diffusion occurs in the kidneys. When breathing, diffusion of oxygen and carbon dioxide occurs inside of your lungs. Because we are surrounded by heat and mass transfer properties and they are instrumental in our survival, we were motivated to further analyze mass transfer. Our goal was to design and demonstrate an interesting experiment that would be appropriate in explaining mass transfer to high school students. We decided to focus on carbon dioxide diffusion in the process of baking cookies. This experiment was chosen because of its relatability, ability to be demonstrated, and its ability to be connected with other examples of diffusion in the chemical engineering industry. Carbon dioxide diffusion is an example of mass transport that most people have experienced, but do not think about or understand. Carbon dioxide diffusion also relates to other mass transfer processes in the chemical engineering field, both in the food industry and other processes of diffusion. We used basic cookie ingredients. To emphasize how this type of mass transfer is used in baking, we altered the control recipe in 3 ways. In variation 2, there is increased acid concentration from the sugar. Brown sugar contains acid, and increased acid allows for higher generation of CO2 with increased baking soda content. While baking soda is simply sodium bicarbonate, a base, baking powder is comprised of both sodium bicarbonate and the acid it needs to react, which is then activated in the presence of water.
Mass transfer occurs when there is a concentration gradient present in the mixture or medium. In the experiment, carbon dioxide must be generated in the cookie sometime between the mixing of the ingredients and when the cookies are finished baking. The key ingredient that produces carbon dioxide by chemical reaction is baking soda or baking powder. The production of carbon dioxide creates the concentration gradient between the center of the cookie and the atmosphere surrounding it. This gradient allows diffusion of carbon dioxide from the center outward, pushing the dough and causing it to rise. Once the cookies are spread and start baking, the heat catalyzes the reaction and largely increases the production of carbon dioxide. Our results show that increasing the amount of baking soda without also increasing the amount of acid, or molasses in brown sugar, does not increase the height of the cookie. However, there is a small increase in the diameter. It makes sense that if there is not enough acid present to react with sodium bicarbonate, then adding additional baking soda will not generate more CO2. We did not expect that baking soda amounts greater than the regular recipe would not create a taller cookie. We assumed that the regular recipe had close to the required amount of baking soda to completely react with the brown sugar. If we repeated the experiment, we would test smaller quantities of baking soda. Our goal was to design and demonstrate mass transfer to high school students. Using basic ingredients, we demonstrated mass transfer by the diffusion of carbon dioxide and its effects on the rising of a cookie. Mass transfer is the net movement of mass from one location to another. Mass transfer occurs when there is a concentration gradient present in the mixture or medium. An important aspect of the reaction is what acid is present to react with sodium bicarbonate and its quantity. Chemical engineers contribute to problem solving in the real world in countless ways. In industrial settings, chemical engineers oversee maintaining, improving, and inventing processes that involve the transfer and production of gases, liquids, and solids. Chemical engineers are involved in industries ranging from energy, consumer goods, and health. As mentioned earlier, the type and quantity of acid present has an effect on the baking process for cookies. A chemical engineer could test which combination of acid and its amount produces the most optimal product in terms of cost, size, texture, and baking time. In addition, a chemical engineer could design the entire process to produce the cookie, beginning with the mixing to shaping, baking, and packaging. In research, a chemical engineer can be involved with nanotechnology, sustainable energy, materials, polymers, complex fluids, microfabricated systems, cellular engineering, catalysis, and reactions.